This is part 2 of probability, focusing on sample space and tree diagrams. Sample space is another word for all possible outcomes of an experiment, everything that could happen in a given event. So, for example, if I took all the letters from the word math and put them in a bag and said I was going to close my eyes and draw out one of the letters, N or A or T or H, my sample space or my possible outcomes are all the letters of the word math. And you should immediately think that you have an equally likely chance of pulling all of these because there's one of each of them, and there are 4 letters, so the probability of pulling each letter is 1 out of 4, and those are equally likely. This is a fair event. I can organize the sample space in a list or a chart. For example, if I wanted to see what are my possible outcomes of rolling a die, I could list them 1 through 6 here. Or I could also show my sample space in a chart. In this experiment, I'm going to spin this spinner 2 times and then find the sum of my 2 spins. So I would create a chart where I would show all the possible combinations, like I could spin a 1 both times, or here I could spin a 2 both times, or a 2 and a 3, and then I would record the sums. And my sample space would be all of the possible sums that I could get, 2, 3, 4, 5, and 6. I don't have anything bigger than 6 or anything smaller than 2, so this is a list of my sample space. Now that chart was helpful, but not necessarily as useful as possible in order to determine the probabilities of each of those events, of each of those sums. So if I'm doing, if I would need to find the probability of an event that has several different steps, a good thing to do is create a tree diagram. And a tree diagram is an organized list that shows all possible outcomes for an event. So let's show a tree diagram for the same experiment. I'm going to spin this spinner 2 times. So I'm going to first list all of my possibilities for the first step, or spin number 1. So I could spin a 1, or spin a 2, or spin a 3. Then I'm going to draw a branch, and for each of these possibilities, I'm going to show all of my possibilities on the second step. So if I had spun a 1 the first time, I could still spin a 1, 2, or 3 the second time. And if I had spun a 2 the first time, I could do these 3 choices. And if I had spun a 3 the first time, I still have all of these choices. Then I would choose again to show my sums here. And now it's easier to see because I can see all the combinations. It's easier for me to determine the probabilities. So I can see that I only have one combination that'll give me a sum of 2. So the probability of spinning a sum of 2 is 1 out of 9. I see here 2 combinations that would give me a sum of 3. So my probability of spinning a 3 is 2/9, or 2 out of 9. Looking for 4s, I see 3 combinations of 4. So my probability of spinning a 4 is 3 out of 9. And then there are 2 5s and only 1 6. So by creating a tree diagram, it would be easier for me to then figure out the probability of each of those sums. Here's a second example of a tree diagram and how it would help you find the probability of an event. Here's an experiment. If I close my eyes and I reach in my laundry basket and I pick out a pair of pants and a shirt, what's the probability that they're going to be the same color? Well, here's what's in my laundry basket. Brown pair of pants and a blue pair of pants, and then 3 shirts, red, green, and blue. So I'm going to create a tree diagram where first I'm going to show the choice of pants. So it's possible to pick brown pants or blue pants. Then I'm going to create branches off of each of those and show all the choices of shirts. So if I pick brown pants, I still have 3 choices of shirts that could happen. And if I pick blue pants, I have the same 3 choices of shirts. Now, in order to find the probability that I'm looking for in my story, I'm going to look for the favorable outcomes, which are combinations where my clothes are the same color out of all the possible outcomes. So I had only one combination where the clothes were the same color. Here it is, blue pants and blue shirt, so I put a 1 on the top. And you can see by counting the last row of this tree diagram that I have 6 different combinations. So there are 6 possible outcomes. And I hope that your brain is thinking, oh man, that's pretty unlikely that I'm going to have a combination where they're the same color, because 1 out of 6 is less than 1/2. It's possible, it's more than 0, but it's less than 1/2. And when we have a probability that's between 0 and 1/2, we call it unlikely.